Welcome back to Fun Facts Online. Today, we are diving straight into the invisible machinery of the new digital gold rush. For decades, the internet ran on a relatively simple, unspoken social contract. It was a deal we all implicitly agreed to. You, me, independent creators, and massive publishers provided free content to the public. In exchange, search engines indexed that content, driving traffic, eyeballs, and ultimately, advertising revenue back to the creators. It was a beautiful, symbiotic economic loop. That very loop built the trillion-dollar foundation of Web 2.0. But the meteoric, explosive rise of generative artificial intelligence has fundamentally shattered this social contract. We have traded a cooperative ecosystem for a unilateral model of mass data extraction. Only this time, the resource being aggressively strip-mined is not oil, and it is not silicon. It is human knowledge. It is our creativity, our history, our art, and our everyday conversations. Welcome to the new reality of the internet. Think about the underlying engine of the modern AI revolution. Large language models and diffusion models rely on an unimaginably vast intake of data. To build systems capable of passing the bar exam, writing functional computer code, or generating hyper-realistic art, AI developers had to harvest the entire internet. Blogs, news articles, academic journals, decades of Reddit threads, Wikipedia pages, and millions of digitized books were scraped, parsed, and fed into neural networks. And the stakes are astronomically high. The AI industry is barreling toward a projected global market size of over $2.48 trillion to $3.58 trillion by 2034. But the economics of how this data is harvested, managed, and monetized are undergoing a violent transformation. The era of free, open web scraping is colliding head-on with copyright law, the exhaustion of high-quality human data, and an outright rebellion by the very publishers whose work trained the machines in the first place. Let us look under the hood at the hidden infrastructure of web scraping. To truly understand the economics of AI data harvesting, you first have to understand the sheer, mind-boggling scale of the operation. Modern large language models are not trained on gigabytes or even terabytes of data. They are trained on petabytes of raw text. We are talking about trillions of linguistic tokens. A token is essentially a fragment of a word, the basic building block of AI comprehension. Historically, AI labs relied on massive open-source datasets like Common Crawl. Common Crawl is a non-profit repository that archives billions of web pages. It was a goldmine. But pulling data from the internet is only the first, and arguably the cheapest, step in the pipeline. The true economic burden of data harvesting lies in the refinement process. Raw web data is inherently chaotic. It is a nightmare of information. It is riddled with spam, SEO-optimized garbage, toxic speech, duplicated content, and poorly formatted HTML boilerplate. If you feed that raw data into an AI, you get a completely broken model. To make this data digestible for machine learning algorithms, companies must invest heavily in AI data management. This is a highly specific sector of the tech economy that was valued at roughly $25.5 billion in 2023, and it is projected to skyrocket past $104 billion by 2030. The cost structure of building a machine learning dataset involves several distinct, incredibly expensive phases. First is extraction and proxies. As websites become increasingly hostile to automated bots, scraping requires highly sophisticated infrastructure. AI developers and data brokers must route their crawlers through vast networks of residential IP proxies. This is done to bypass anti-bot protections and CAPTCHAs, incurring significant bandwidth and networking costs. They are effectively masking their digital footprints to vacuum up the data. Second is compute-intensive filtering. Cleaning petabytes of text requires massive cloud computing power. Algorithms must run deduplication processes. This ensures the model does not over-index on repeated phrases and start repeating itself in endless loops. They also run language identification and heuristic filtering to strip out useless navigational menus and boilerplate web code. Third is toxicity and personally identifiable information removal. To prevent models from generating hate speech or leaking personal phone numbers and home addresses, expensive algorithmic classifiers must scan the entire dataset to sanitize it. This is a computationally heavy, mathematically intense process. And fourth, The most expensive layer of data curation is not automated at all. It is strictly manual. It is called reinforcement learning from human feedback, or RLHF. This requires literal armies of human annotators. These are often gig workers sourced from developing nations who spend hours every day ranking AI outputs, writing high-quality prompts, and correcting factual errors. When an AI company proudly announces a shiny new foundational model, the billions of dollars spent on hardware and GPU clusters often overshadow the hundreds of millions spent on assembling, cleaning, and refining the dataset. That dataset is the software fuel that makes the hardware matter. But how did we get here? For years, AI companies operated under the classic Silicon Valley mantra of move fast and break things. They utilized the legal gray area of fair use to justify scraping copyrighted material from the web. The argument was incredibly clever. They claimed that AI models do not actually store the original text. Instead, they analyze it to learn statistical patterns and the mathematical relationships between words. Therefore, the output is legally transformative. It is learning, not copying. But as these models evolved from experimental research projects into massive commercial products generating billions in recurring revenue, the original creators of that data revolted. They realized their life's work was being monetized by someone else. The turning point arrived with a flurry of high-stakes copyright lawsuits that are actively reshaping the entire AI data economy today. The most monumental of these battles is the New York Times versus OpenAI and Microsoft. The Times alleged that millions of its copyrighted articles were scraped without permission or compensation to train models like GPT-4. Crucially, the lawsuit demonstrated that under specific prompting, these massive models could regurgitate New York Times articles almost verbatim. This effectively bypasses the publisher's paywall and directly competes with its core business model. The Times did not just ask for a financial settlement or compensation. They went for the jugular. They sought statutory damages and the outright destruction of any AI models trained on their proprietary data. This landmark case opened the floodgates. The Times later escalated its legal war by suing the AI search engine Perplexity, accusing the startup of illegally crawling its journalism, producing near-verbatim summaries, and even fabricating information falsely attributed to the publication. These lawsuits highlight a massive, fundamental economic paradox at the heart of the AI industry. AI models desperately require high-quality, professionally vetted data to sound authoritative and intelligent. Yet, their very existence undermines the financial viability of the institutions creating that data. By providing users with comprehensive, zero-click summaries, AI search engines drastically reduce the click-through rates that news outlets and independent blogs rely on for advertising and subscription revenue. The machine is effectively starving its own host. If the creators go bankrupt, the AI loses its source of fresh knowledge. While some courts have shown leniency toward AI companies, such as the recent dismissal of a copyright lawsuit filed by the digital publisher Raw Story against OpenAI, the legal friction has permanently altered the economics of dataset creation. Scraping the open web is no longer a risk-free endeavor. The Wild West is over. Faced with mounting legal fees, the constant threat of injunctions, and an increasingly closed-off internet, where major websites now aggressively block AI web crawlers via their robots.txt files, the AI industry has been forced to pivot. The era of unauthorized harvesting is slowly but surely giving way to the era of high-stakes proprietary data licensing. The new rule of the internet is simple. If you cannot legally take the data, you must buy it. This massive shift has created a highly lucrative new revenue stream for legacy platforms holding massive archives of high-quality human text. In recent years, we have seen major tech conglomerates strike multi-million-dollar deals to secure exclusive access to training data. Take Reddit, for example. It is a treasure trove of authentic, highly diverse human dialogue. Reddit recently struck a licensing deal with Google, valued at roughly $60 million per year, allowing the search giant to train its AI models on user-generated subreddit content. Similar licensing agreements have been brokered between AI labs and major publishing conglomerates like News Corp, Axel Springer, and Stack Overflow. But this economic pivot creates a profound barrier to entry in the AI market. When the internet was treated as an open, free resource, open-source developers, academic researchers, and small startups could train highly capable models in a garage. But if the future of AI training relies on negotiating nine-figure licensing deals with massive publishers, the market will inevitably consolidate. Only the tech giants with the deepest pockets, companies like Microsoft, Google, Meta, and Amazon, can afford to legally acquire the vast troves of data required to train next-generation frontier models. The cost of data has become a formidable, almost impenetrable economic moat. It freezes out the little guy. But there is a shadow looming over the economics of AI data harvesting. It is a physical limitation that all the money in Silicon Valley cannot solve. The world is simply running out of high-quality human text. Researchers refer to this terrifying bottleneck as the data wall. Estimates suggest that foundational AI models have already consumed the vast majority of the digitized, high-quality text available on the public internet. The classic books, the reputable news articles, the scientific papers, and the well-moderated public forums have all been completely digested. What remains on the internet is largely low-quality data. We are talking about spam, auto-generated SEO blogs, and redundant, poorly written social media chatter. If you use this low-quality data in training, it actually degrades the performance of the model. It makes the AI dumber. As the supply of fresh, high-quality human data dwindles, the economics of dataset generation are shifting toward a highly controversial new frontier: synthetic data. Synthetic data is exactly what it sounds like. It is data generated by AI, specifically for AI. Instead of scraping human-written articles, AI companies use their most powerful, capable models to generate millions of hypothetical scenarios, step-by-step reasoning logic, and complex coding problems. These artificial outputs are then used to train smaller or next-generation models. Economically speaking, synthetic data is incredibly attractive. It completely bypasses all the copyright lawsuits. It eliminates the need for expensive web scraping infrastructure. And it can be generated on demand to fill specific knowledge gaps. For instance, you could generate millions of highly detailed medical diagnostic scenarios to train a healthcare AI without ever violating real-world patient privacy laws. However, synthetic data carries its own unique existential risks. The most notable is called model collapse. If an AI is trained purely on the outputs of other AI models, the data pool essentially becomes an intellectual echo chamber. The strange quirks, the subtle biases, and the factual hallucinations of the generating model become amplified and exaggerated in the receiving model. Eventually, this leads to a complete degradation in logic and output quality. It is exactly like making a photocopy of a photocopy of a photocopy. The image eventually becomes a blur of unrecognizable noise. To prevent model collapse, companies still desperately require a continuous, albeit smaller, injection of pristine, newly generated human data to act as an anchor to reality. Human ingenuity is still the ultimate ground truth. As text-based data harvesting violently hits its ceiling, the AI market is rapidly expanding its appetite to encompass multimodal data. The new frontiers of data harvesting are audio, video, spatial data, and deeply specialized enterprise data. The AI in data analytics market is projected to soar from $31.22 billion in 2025 to over $310.97 billion by 2034. This staggering growth is largely driven by massive industries finally recognizing the value of their proprietary, unstructured data. Let us look at the banking, financial services, and insurance sector. Financial institutions are sitting on decades of highly confidential transaction histories, global market behaviors, and complex risk assessments. They are investing heavily in AI data management tools to sanitize this massive trove of data internally, training bespoke models for predictive analytics, hyperfast algorithmic trading, and advanced fraud detection. Next is healthcare and biometrics. Medical imaging, anonymized patient health records, and genomic sequences are incredibly valuable datasets. The economic incentive to harvest and structure this data is astronomical. AI models, capable of discovering revolutionary new drugs or diagnosing extremely rare diseases, require massive, highly specific datasets that simply cannot be scraped from a public blog. The data has to be cultivated. Then you have audio and video. With the rise of models like Sora and incredibly advanced voice assistants, Platforms hosting video and audio are becoming the absolute center of the new battlegrounds. Transcribing millions of hours of YouTube videos, podcasts, and public broadcasts has become a standard, automated practice. This brings the exact same copyright and fair use arguments previously seen in the text domain directly into the multimedia sphere. If you speak into a microphone or upload a video, your voice and your face might become training data. Finally, the economics of AI data harvesting cannot be viewed in a vacuum. It is a critical, foundational component of global geopolitical strategy. In the modern era, data is widely recognized as a highly strategic sovereign asset. Whoever controls the best data controls the future of artificial intelligence. North America currently dominates the AI market, capturing around 30 to 32% of the global market share in recent years. This dominance is largely due to the massive concentration of hyperscale cloud providers and the simple historical fact that a vast majority of the early internet's top-tier data was originally generated in English. However, the Asia-Pacific region is experiencing explosive growth. We are seeing incredibly aggressive government initiatives aimed at mass AI adoption across all major industries. The real geopolitical tension lies in data accessibility and regulation. Regions like Europe are enforcing extremely strict data governance through frameworks like the General Data Protection Regulation and the newly minted AI Act, which places heavy, uncompromising restrictions on how personal data can be scraped and used. Realizing they might fall behind, in 2025, the European Commission even launched a $225 billion AI Continent Action Plan to try and remain competitive. They are actively funding massive gigafactories focused entirely on training foundational AI models. Conversely, nations with fewer legal restrictions on copyright and data privacy can theoretically harvest and train on vast global datasets with absolute impunity. This creates a potential, terrifying asymmetry in the global AI race. If Western tech companies are constantly bogged down by years of copyright litigation and forced into expensive multi-million-dollar licensing agreements, state-backed entities in competing nations could gain a significant economic advantage by simply continuing to scrape the open web indiscriminately. The rules of engagement are totally uneven. The economics of AI data harvesting represent a fascinating, incredibly high-stakes evolution of the global digital economy. Make no mistake, we are witnessing the end of the open web as we knew it. The initial phase of AI development was essentially a massive smash-and-grab operation, heavily reliant on the unfettered, zero-cost harvesting of the digital commons. But as the severe legal, physical, and economic realities of this practice set in, the industry is transitioning into a mature, highly structured, and ruthlessly competitive market of data brokerage, synthetic generation, and multi-million-dollar exclusive licensing deals. The ultimate question moving forward is not whether I will continue to consume data. It absolutely will, to the tune of trillions of dollars in market capitalization. The real question is how the creators of that data, you and me, will fit into this new economic hierarchy. The immense challenge of the next decade will be establishing a balanced framework. We need one that continues to fuel the extraordinary, world-changing human progress brought about by machine intelligence, while desperately ensuring that the humans generating the foundational knowledge are not permanently economically disenfranchised by the very machines they helped create. Thank you so much for listening to this episode of G Fun Facts Online. If you want to understand the future, you have to follow the data. Keep questioning the world around you, stay curious, and we will see you in the next episode.